Okay, SV1000 Sport, 24,000 Ks on the clock with the stator cover removed. Did it to check out the infamous migrating stator magnet issue and to see if it was on this bike. And lo and behold, five mil gap, 5mm gap, 5mm gap, 5mm gap. Grand Canyon, no gap. All the magnets appear to be stuck on pretty well, bar this one here at the bottom. These things are like fine china, so you have to be really careful. One free stator magnet, free to slosh backwards and forwards on the flywheel and smash against the other magnets, break up and have some fun with the internals of the engine. Very lucky. Appears to be failed epoxy. Not good enough, Suzuki. You need to come to the party on this issue. There's a lot of engines that have been destroyed. Okay, gone away for a couple of days. Written a couple of grumpy emails to Suzuki. Had one response from them which hasn't been too satisfactory, but I thought regardless I'll just push on. Just a couple of things to note. First thing, if you have a look at the adhesive here, so it's a bit hard to do this one-handed, but this is the epoxy here. I don't know if you just saw that, but it's very easy to break up. And actually if you look over on this corner here, once again, one-handed's a bit difficult when you've got a magnet pulling you everywhere. But this bit in here, if I chuck it, you'll see that that bit's already come loose. So I wouldn't be surprised if there's little fragments of epoxy already floating around in the oil and possibly already caught up in the strainer somewhere. You'll see this one here, I've just, I can get it to stick to my finger. There you go. So there's a nice hard piece of epoxy right there. Righto, back on the job. You'll see here that I've actually marked up the flywheel magnets and the positions on the flywheel itself from 1 to 6. That was just in anticipation that I was going to be able to remove some of the ones that were maybe less bonded or about to come off. And given that this thing sort of, the red line on this bike's 11,000 RPM, I did some sort of calcs on what could happen if it was out of balance, and it wasn't great. So just trying to maintain balance as much as possible. Obviously when you've got a magnet that's not in the position it's supposed to be anyway, the balance is never going to be good. But you want to try and maintain that as well as you can when you're doing the repair. So I did try and get the magnets off, or try and remove the ones that potentially were suspect. I didn't know which ones were suspect or if any indeed were. I basically heated up the flywheel itself just gently with one of these. Sort of got it to around about 100, 120 degrees C. I think it was too hot to touch. And then just gave it a little gentle little tap with a bit of timber and a hammer, just sort of tapping here and trying to shear them off. Couldn't get them to budge, so I'm not sure if that's a good sign or a bad sign. Would have liked to have been able to get them all off and re-glue them properly, but given the fragility of these things, and the fact that once they're broken, they're very hard to source new ones. You basically have to buy a whole new flywheel because actual individual magnets snapped up pretty quickly in the marketplace by people with the same issue that I've got. So essentially I've just resigned to the fact now that we'll glue the one that had come unstuck back on, and then I'll go on and reinforce the areas in between the magnets with some spacing fillets. The materials that I'm going to use for that is Loctite 620. It's rated to sort of in the high 200s in terms of temperature capability. It's also rated for oil immersion. So in a crankcase environment in a motorcycle should be okay. This is what a lot of the other people use. A lot of other people use sort of lower grade Loctites, but I thought I'd go for the best that I could buy. It's about 56 Australian for a bottle, so it's not cheap, and you can only get it in 50ml bottles locally, although there are some 10ml bottles that you can get online, but I was in a hurry. The other product for the fillets in between the magnets is JB-Weld, and this once again is rated into the 200s. I'll be interested to see how this goes. It's actually got a metal filler in it to help with strength. And apparently when you start putting it in between the magnets, the metal filler tends to make the epoxy migrate while it's setting. So I've fabricated some little templates or little walls to try and prevent this happening. So we'll see how that goes. Righto, moment of truth. So just a couple of quick things before we glue this thing down. So I've gone through and given this surface a bit of a rough up, just with some sort of wet and dry emery paper. I think it's a grade 120 or similar. A lot of there's very fine machine grooves which are sort of in the axis of rotation. And given these things will slide along those same grooves, I thought I'd try and put some scratches in the opposite direction just to provide the glue to key, something to key into. And I've sort of done a similar thing. I cleaned the glue off. Don't know if you can see it here. Just cleaned the glue off with some sandpaper and gave it a good clean. Probably the biggest challenge I found with this is actually getting all the surfaces clean of oil. It can be a real challenge. You give it a good clean, then you come back an hour or two later and it sort of feels oily again. So even, after I use brake cleaner, isopropyl alcohol, I even use a little bit of detergent at some stage just to try and get everything really squeaky clean. Anyway, probably the only other thing, I've made up some spaces, just go between the magnets. These are just tile spaces, 5mm. I've added a bit of tape to get them out to 5.5, which is what the measured gap is. Give this a go. Try and put a good covering on. Not sure how much is too much. Ooh, it really does try and skate around. We'll get these spaces in. I don't know if you saw when I put it on, the magnets try and attract to each other. These are polarised so that they're opposites. So you've always got an opposite magnet next to the one next to it. So as soon as you put it down on a glued surface, it's very, particularly if it's slippery while it's still setting, it tends to want to escape one way or the other. It's just if you do this yourself, just make some spaces up before you do it. It makes the job a lot harder if you don't. Okay, so we'll see how that goes. Just whacked a little clamp in the middle just to provide a little bit more downwards force. We'll leave that overnight to cure, and then we'll come back and we'll start doing the JB welded fillets. Just while I've got the camera rolling, have a look down there. They're all the little bits of epoxy that I chipped off in between the magnets there. And when I say chipped off, I actually just used a box cutter to saw off the excess. So if you have a look around, hopefully you can see there. Actually, I'll just get a bit more light. You'll see that I've sawed off the excess epoxy. Just because you don't want it there, because it's going to flake off in future anyway. Seems to be that anything that's not under magnets and it's floating out in the oil just goes to shite and comes off. Alright, back from letting this set overnight. I've removed the spacers and the clamp. I've given it a bit of a pull with my hand and pull and a push, and it seems to be stuck on, which is good. Just a point of note, it's a methyl acrylate anaerobic curing type product, so any sort of run out that you see at the sides won't cure. Then you'll have to remove that. So if I chuck a cotton bud, I'll demonstrate that here now, if I can get that in focus. So that's still pretty wet. So anyway, I'll get all that cleaned up before I put the JB-Weld in between the magnets. Righto, we're all masked off and ready to go here. You'll note that I've put in little side dams at each end, so it's just a bit of takeaway container plastic that I've cut. Just marked it out with a compass, inner and outer diameters, cut it along the line and put it in here. So you'll see there's one at the back as well. The one at the back has to be slightly smaller diameter, just due to the lip that the magnets rest against. Made up a couple of tools to put it in. That's just so I can get in nice and deep and push it all into the spaces. And then I've just got a plastic spatula to smooth the top once I get it filled up. As I said, due to the metal content of this epoxy, it's prone to migrating under the magnets. There's a little bit of trepidation as to what will happen, but hopefully it won't be too bad. So anyway, I'll get the JB-Weld mill mixed up and we'll go from there, and next shot hopefully we'll be all done. Just finished packing the first two gaps between the stator magnets. Probably a couple of, or one interesting point. So look, these little side dam thingies that I've put here work really well, so I highly recommend that along with the masking. The JB-Weld tends to migrate sort of in weird ways with the metal content. If you see at the back here, there's a little hole that just keeps opening up every time you plug it. It just sort of eddies around and opens up. I did some reading before doing this. Apparently a way around it is to let it sort of harden a little bit and then refill. So probably just a point, if you're doing this yourselves, just keep that in mind, that you're going to have to probably just do a little bit of a multi-application approach. Okay, back after letting this cure for 24 hours. Was a little bit fiddly. I did a quick Google and found that the JB-Weld sticks to pretty much everything except rubber, I think, canvas and polypropylene. So then I got some polypropylene, more polypropylene container lid, and just cut it to size and stuck it down. I've actually removed these already, that's why they're just sitting there. I'm just demonstrating how they were put on when I did it. But that seemed to stop it moving around quite well. It stopped it sort of eddying and flowing. So I pushed them well into the mix, and then this morning I've just, as you can see, I've ripped them off, and they give you a really nice clean finish. So I'll get the rest of this tape off and we'll just see what it looks like underneath. Okay, that's after removing all the masking tape. Job looks pretty clean actually. There's a little bit of run out at the front on the side dams, and I think there's a little bit at the back as well, but I've just had a bit of a feel with the box cutter or razor blade, and you can sort of, because it's cured but it's not 100%, and I'll rephrase that, it's set but it's not 100% cured yet, so it's still a little bit workable. So I'll get it cleaned up a bit more, and then possibly give it a bit of a sand as well, and then we'll go from there. Okay, just finished sanding. Hasn't come up too bad. There's a little bit of a void on the right hand one just at the front, you'll see there. I'll probably have to fill out later because I don't want oil getting in there. Just a word of note, they see all the filings. As mentioned earlier, it's got metal in it. This epoxy's got metal in it, so you've really got to, if I zoom out a bit, you'll see here I've packed the left hand side of the crankcase with an old t-shirt and just closed up every void because you don't want this stuff getting into the engine. I'm just going to give this a quick vacuum off and we'll see how we go. We'll get on to the next two. Righto, first two stator magnet gaps filled and completely sanded and ready to go. You'll see I've cleaned it up with a vacuum cleaner and then given it a wipe with a rag. There's a fair bit of, well, not a fair bit, but there's still a little bit of what I'd term as swarf sitting around on the magnets, so it's going to be a bit of a job to clean towards the end. Yeah, you just got to be clinical about these things is what I've learned, to try and avoid it getting into the engine. So at the end, when I've done the other four, I'll give it a proper clean. Just a couple of notes. It's definitely worthwhile using a Dremel in conjunction just with some emery paper. I'm using two bits. I'm using a wire brushed bit and also a little sanding disc, sanding barrel or cylinder. It's quite a rough, I don't know what the grit grade is in this, just looking at it's probably about an 80. I just use it at really low RPM. Just do it along here. You just got to be careful because magnets pull you in all sorts of directions, so you can, if you're not on the ball, you'll take gouges out of your handiwork. So just a point to note. The other thing is the wire brush is good for getting in behind, you see here, getting in behind the magnets, because there's a little bit of a little bit of spillover out the back there as well when I was when I was pushing it in. Anyway, pretty happy with the initial result. I think I'll continue and do the other four magnets with 4 gaps with this progress and with this process, and then we'll get it all back together, hopefully. Happy days. Righto, it's been a couple of days since I've been out to the shed. It's been pretty cold here in southern Australia. It's 0 degrees this morning, so I didn't really feel like sitting out here talking to myself in the freezing cold. But anyway, it's a much nicer afternoon, so I thought I'd pop out and do it now. Also had to pop out in the meantime and grab another gasket and some oil. Just a note, you'll lose about half a litre of oil with the bike on a track stand or a centre stand, so you'll need to top up the oil a bit. So anyway, job done. I think it's come up pretty well. Look, there's a couple of little bubbles that you'll see. There's one here, there's one here, but overall it's looks to be a pretty robust fix. Just on the subject of robust fixes, there's a couple of sort of aspects that I'll talk through now, and I'll try not to waffle on too much, but probably the first one was just the communication with Suzuki and trying to work out whether they had a recommended fix for it or not. I'll get into that. And the other was just looking at this from an engineering analytical perspective, just to make sure that this JB-Weld fix, I know there's tons of people out there using it, but I just wanted to satisfy myself that it was going to be something that was long lasting, given that this bike's only got a few Ks on it and I'm hoping to own it for a while yet. So I'll sort of go into both of those now. Okay, so moving on to the first discussion item was just the correspondence that I had with Suzuki. I rang Suzuki here in Australia, and they said that they didn't have a telephone line to talk through engineering related issues on motorbikes, so they gave me an email, which was to their technical sort of service desks. So anyway, I emailed them initially on that address, just outlining the issue I had. I sent a couple of photos of the detached magnet here, and just asked them, A, are they aware of the issue, and B, what the recommended fix that they have for it, and C, if they're aware of the JB-Weld fix and is it something that they would recommend doing. So the answer to the first question was that they weren't aware of the issue. Surprise, surprise. Kind of disappointing, but not surprising, I suppose. Secondly, they said, look, in the case of my motorcycle, I should go out and buy another generator rotor. Apparently this is what these are called according to the manual. I just found that out about 10 minutes ago when I was checking torque settings for these bolts here. And then they also went on to say that the JB-Weld fix, look, I didn't say whether they were aware of it, but they just said they don't recommend putting any unvalidated or tested epoxy into the crankcase environment, which wasn't surprising either. So they went, and basically they recommended that I go and buy one of these new generator rotors. So I went back and said, well, if I'm going to outlay 600 odd Australian for one of these things, can I guarantee that it's not going to fail in the next sort of 10 to 20,000 Ks, i.e. is the new generator rotor a new fixed design level, or is it the same as the original OEM fitted items? They came back and basically said that there's no design change that they're aware of on this generator rotor. So I basically concluded from that, and I'll put this in writing back to them as well, that if I go and buy one of these things, I can expect to see a failure in the next 10 to 20,000 Ks. And I never heard back from Suzuki confirming or denying it. And I think I put something in my email around the lines of, concluding that this is the most cost-effective and reliable fix that's known currently, but they haven't come back, obviously. So anyway, that's a little bit about my pissing match with Suzuki. So based on what Suzuki came back and the conclusion that I was going to go ahead with the JB-Weld fixed, I kind of wanted to satisfy myself that I was going to do this once and once only. I didn't like the idea of A, magnets coming loose in future, or B, whatever I'd use to fix it in terms of this filler coming loose in future as well. So I sort of did a fair bit of research online just on the JB-Weld product itself and the Loctite product that I used, as well as just some sort of dynamic use type calculations that I did, pretty rough sort of engineering type stuff. So there were sort of four aspects that I looked at. I looked at balance, I looked at hoop stress, I looked at hydrostatic pressure of trapped oil, because you're going to get oil trapped in here, and that was one that was significant. I'll get to that in a minute. And then I did a couple of, I won't call them abuse cases, but use cases where you might accidentally slip it into first while you're at the lights without engaging the clutch, or disengaging the clutch, I should say. So it's basically a stall case. And then I did some clutch dump cases from, I think I did 5,000 and 10,000 RPM, just to see what the loads were on these magnets. So look, the first one was balance, and this sort of goes into the radial force that's exerted against the generator rotor at high RPM. I did 10,000 RPM as a study case. These magnets weigh about 75 grams each. I weighed the one that I removed. You'd be surprised, the force at 10,000 RPM calculated out to about 5.6 kilonewtons. You convert that to kilograms, it's about 570 kg. So each one of these little buggers exerts half a tonne of force at 10,000 RPM in the outward direction, or the radial direction. And if you sort of put that in the context of when all these things bunch up on one side, when they're all unattached or detached, you can get a pretty good feel for how bad it is for balance and what it's doing to the bearings inside the engine. The other thing that I learnt, or just calculated out, for every gram that you add here in terms of this filler, adds around 8 kilograms or 75 newtons of force at 10,000 RPM. So you want to try and, if you can, get these as identical to each other as possible, just so that you're not throwing the balance out. Look, at the end of the day, any fix is going to be better than what you've come from, but if you want to, if you're a purist and you're trying to maintain balance, it's probably a good idea just to try and adhere to that philosophy. Second study area I looked at was hoop stress and hoop strain. So this is a kind of one sort of solid hoop, and I suppose the best way to sort of describe what I'm trying to understand here is when you look at a top fuel dragster at a race meet and it's doing a burnout before it does a run, and the tyre diameter increases, you know, by about, I don't know, 25% in some cases. You really see them expand. So steel's no different. And the main reason why I did that was twofold. One was I just wanted to understand what sort of stress it was going to put the epoxy filler under, and B, whether there was any likelihood of opening up a little gap in these joints at high RPM, because if you're cycling it over a long period of time, eventually the bond, you know, if the expansion of this or the increase in circumference of this is significant enough, you're going to end up with a bit of a gap opening up, or minute gap, and eventually oil and contaminants get in and will, over time, weaken the bond. What I found, thankfully, was there was no great surprises here. I think overall, so I'm just having a look at my notes. I've done a bunch of calculations and notes down here. Overall, the total length change was, or total circumference change was 0.01 at 10,000 RPM. So that's over the entire circumference, so it's negligible, I think. I'm pretty sure that, you know, bonding strength of this plus the fact that it's able to stretch and contract a bit, or expand and contract, will eliminate, or to that, eliminate the possibility of any gaps opening up pretty close to zero. Third item was hydrostatic pressure, and I mentioned this earlier, where you no longer got any way of the oil escaping from this lipped area in behind here. So, and generally spinning things will create a little bit of a vortex from an airflow point of view. They can draw things in the middle, like a bit of a centrifuge, and then throw them out at the sides, and you've got a nice lip area here to capture oil. It's about 5 or 6 mil depth of oil in here, I think. So hypothetically, if this whole ring was to fill up in operation, you'd have 5 to 6 mil depth of oil. When you're doing 10,000 RPM, I didn't write the G value here, but it's quite a lot more, and it came out, the stress came out to be, or the pressure I should say, in here came out to be 3.5 megapascals, which in old school is 514 psi. So if you do a bit of a calculation on the axial pressure that's pushing out against this side of the magnets, for the whole generator, rotor, and also, so for the whole 6 magnets, it came out to be 3.8 kilonewtons, right, which is a fair bit. It's probably the biggest thing that surprised me of all the calcs that I did. So if you look at that, it's about 65 kilograms on an individual magnet, on each individual magnet at 10,000 RPM, pushing it out. So that was a bit of an eye-opener. So once again, I think probably worthy just to pause here and comment. I read online a couple of things that sort of didn't really sit well with me, where some people were recommending that all you need to do is glue in between the magnets just with JB-Weld, and don't worry too much about gluing these. Just based on that calc alone, I'd be strongly recommending that you glue both. And two, probably the other thing, I know a lot of people get away with using JB-Weld putty. I did a fair bit of reading, and look, JB-Weld sort of don't have a lot of claims online, but as far as a spec sheet, I couldn't find one. But a lot of people have tested this stuff, and what I did find is any of the alternative JB-Weld, say your JB-Weld Quickset, your JB-Weld putties, from a bonding point of view, actually bonding to the metal, a lot of the online tests that I saw, they don't bond anywhere near as well as the liquid epoxy original. So getting that 5,000 and I think 20 psi bond rating, one guy online did a really good structural test using a proper load cell, and he was able to replicate it with this. But with the other types, he got nowhere near it. So it's just something to keep in mind, that I think if you're going to do this and you're going to take the time to open up the side of your motorbike and drain a bit of oil and do all the cleaning and that, use the right stuff and take the time to do it properly. The other thing I saw, some people online were claiming that they'd put this stuff in and then they'd opened up their or taken the stator cover off about 5,000 k's later and found that it was all the filling here was gone. It sort of concerned me a bit as well. But then I read further down on some of those threads where people had sort of said, well, post us a photo of what your job looked like and how you did it. And one guy he posted his job, and essentially all he'd done, it looked like he'd squeezed like a toothpaste, cylindrical toothpaste bead in here and just let it sit between the two magnets as a sort of a pseudo spacer. And to be honest, the job was that bad. It looked like someone had laid a dog turd in there, like a big grey dog turd just sitting there ready to be washed away. So it's a little surprise just with the forces that I was calculating, like on the oil, 3.5 megapascals of oil pushing this way. Of course, it's going to push out anything that's not put in there properly. And you've got to remember that when it does get pushed out, ultimately it's going to end up in the sump and possibly a gearbox. So you really want to make sure that this stuff doesn't, once you put it in, it's not going to go anywhere. The last item I'll talk to is just the extreme cases of use in terms of deceleration and acceleration. This was just to see what the forces on the magnets were in the direction of rotation. So I did a stall type analysis. I did a clutch dump from 5,000 RPM sort of down to 2.5, and then I did a calculation based on a clutch dump at 10,000 RPM. The figures vary widely on this in terms of what assumptions are made in terms of the time component of the rotor deceleration. I got sort of in the range of around, is it 5? So I got anywhere from 500 to 900 newtons. So once again, that's a fair bit. 900 newtons is sort of getting up there in terms of quite a high force. And it just sort of highlighted once again the importance of making sure that everything's bonded pretty well and it's not going to go anywhere. The other item which I failed to mention earlier was just magnetism. There's a little bit of conjecture about whether magnetism was affected by putting a metallic filled epoxy in between the magnets. Just look, based on a screwdriver test, and I know it's not very scientific, but before I put this in, you definitely get a drop in magnetic flux across when you bridge across the gap. I did this test prior to and after doing this fill, and to be honest, just from a screwdriver magnetism perspective, I can't see any perceived change in magnetic flow lines. I think from memory this is a 3-phase generator or alternator, and I'll do a voltage check when I've got the bike back together, but I don't see that the magnetic fill in this epoxy is going to cause any great concerns here. Okay, so I think we're good to go. I'm going to get this back together now, probably just before I sign off. A couple of things to remember: make sure you do a good cleaning and job of the gasket mating surfaces. You can use a razor blade to clean off the old gasket. Just be really careful because the aluminium's quite soft and will gouge. The screws, the bolts I should say, I checked the torque on those in the manual. It says about 5.5 Newton meters each, so I'll call it 6 Newton meters per bolt. Get yourself a new gasket, they're only 25 bucks. You'll need some oil, roughly half a litre. Make sure this washer, if it fell off when you opened, is back on. When you crack the case off initially, like when you're removing it, it helps to put a bit of timber in here or a screwdriver just to hold this gear on, just to stop stuff coming out, because this will all come out and drop off if it's stuck to the case stator cover side. There's a collet here which you probably need to, so if that falls off, just put it back on this gear pin here. There's two dowels, there's one dowel here, there's another dowel on the cover side that mates with this. Both of mine are stuck in the cover, I couldn't pull them out, so I've left them in. Just make sure that they line up when you're putting it all back together. The main reason that these dowels are here is you need good datuming of this stator cover to the generator rotor, because the clearance between the actual magnets themselves and the actual stator coils is only 1 millimetre. So obviously if the cover's not lined up correctly when you're putting it on, you're going to end up with contact on both of those systems, which is never going to end well. So we'll get this back together, I'll do a voltage check, I'll try and post the voltage that I get at the end of the video, and we'll go from there. If you like the video, smash the like button. I think that's what the young trendy folks say. I don't know if I'm that trendy, but if you do like it, hit the like button. And hope to see you all soon. Hooroo.